we are going to actually, this is exciting to me because I love word problems. I don't love them if I can't figure out how to do them, right? Math is kind of awesome when you know how to do it, and there's not quite so awesome when you're stuck, right?
Yeah.
And so, like I said before, my philosophy, so guys, there's a lot of noise. So Luke and Logan, can you put those away, please? They've got to be underneath the table, right? Right, underneath. Because when you make that noise, people near you can't hear me talk, and you should be writing, right? Yeah, thank you. Okay. Where was I going with this? So I'm trying. My philosophy with word problems is to get you so good at a bunch of word problems, so that in the future you'll have so many under your belt that when you see a new problem, you've got all these tools you can use to solve them, right? And then suddenly you're not going to freak out because you're used to word problems, right? So we're going to start with our first set of word problems. Now, before I actually begin, I'm going to do something. I'm actually going to teach this differently than I have ever taught it at this early of a stage of you guys, of people in algebra. Because I usually teach a concept called systems of equations, and that is but I'm not going to teach that. I'm not going to teach, quote, systems of equations, but that's actually the process that I'm using. Systems, all that means, right now, all you guys know how to do is solve one equation. Do you agree with me? One equation with one variable. Am I right?
Yes.
Basically. That's what I've been giving you so far.
Okay.
All right. So that's what I've been giving you so far, where I have one equation with one type of variable, right? So just x's, for example, right? Okay. Now, in these word problems, it's really easy to solve them if you have two variables. But if you have two variables, in order to solve them, you have to have two equations. One variable, one equation. You can solve it, right? One variable. So 2x equals 10. One variable, one equation. Easy, right? You can solve it. So divide by 2, x is equal to 5.
Oh, yeah.
Two equations. If I give you x plus y is equal to 10, can you solve that with one equation? Two variables with one equation? What's x and y?
5, 4, and 6.
It could be an infinite number of possibilities, right? It could be 2 and 8, but it could be 7 and 3, but it could be 4 and 6, or it could be 9 and 250, right? No. So, but it could be a lot of things, but we don't know what it is until we get a second equation. Once I give you this, y is equal to 8. That is an equation. You agree with me?
Yeah.
It's a simple equation. But now, what is x?
2.
It's 2 because you substituted 8 in for y. So now it's x plus 8 equals 10. Everybody understand that?
Yeah.
Does that make sense? Really, really simple, right? Well, we're going to use this process. We're going to have two unknowns, an x and a y. And we're going to therefore have to have two equations. And I think you're going to see the two equations quite simply in these. It's a very awesome way to solve these number word problems. So, all right, our first problem. Number 1. One number. So as I'm writing, please write this down. One number is 25 more than another.
Oh, I know.
Right? Their sum is 65. Find the numbers. Okay? So I'm just going to give you a second to finish writing that. And there is always the guess and check method, right? You could always use guess and check and keep finding numbers that meet up, that match with that. One number is 25 more than another. So I could have a number 1 and then 1 plus 25, 26. 1 and 26. Does that add up to 65? No. I could do 2 and 27, right? right? You see what I mean? I could do a guess and check method. The trouble with the guess and check method, guys, you guys have to really pay attention. Jaden, I'm going to move you if you guys keep talking, seriously, just so you know, okay? Or Jan, I'll move you. I don't know, somebody. But the guess and check method works. It takes time, right? And it's not very fun. I think algebra is fun. I like to set this up as an algebraic equation or two equations, and then it actually becomes fun. So I've got two equations here. I have two sentences. One number is 25 more than another. That is my first equation. That's my first sentence, and I'm going to create an entire equation from that. Now, I am always going to make the first number y. So I underline it, and I put a y over it. And I'm always going to make the last number of that first sentence an x. Okay? And the reason why I do that is because I like, when I use x and y, I like it to say y equals. It doesn't have to. I could use different variables, but I just like that. And the minute it says is, what does is mean in an equation, in math? Equals. Is the same as equals, right? Even in different tenses, if it said was, that would also be equals. Or will be, that's also equals. I didn't talk about that in the lecture yesterday, but that's important to know. So suddenly, I am going to write an equation exactly word for word, all the way across from left to right. So it says one number. What do I write? Y is equals 25 more than. Ooh, what do I do that? That's got to go. I'm going to skip it. I'm going to move that off to the right. I'm going to do this first, x. And then 25 more than plus 25. Does everybody get that? One number, y, is equals 25 more than, I'm going to skip that for just a second. More than what? The x. So I write my x, and then I do 25 more than, plus 25. You see that? Everybody see that? Make sense? Fist to 5, just so I know. We're all on board. Okay. Okay, next question. Next one. It says their sum is 65. How could I write that as an equation? Their sum. Rosemary.
Y plus X equals 65.
Y plus x equals 65. You guys agree with that?
Yeah.
Yep.
Y plus x equals 65. Now, I have two unknowns. I have a y and an x, and I have two equations, right? And it says, find the numbers. I'm supposed to find both of them, right? Now, this is the cool part. It's magic. Remember when I did that other thing up here where you saw I circled what y equaled and I put it into the equation? One of these equations starts with a y equals. Do you see that? Y equals. James, you looking at this? One of these equations starts with a y equals.
Yep.
Right? I'm going to circle what y equals. That is the same thing as y. It's exactly the same thing because it says it's equal to it, right? You guys agree with me? Now, since this is the same thing as y, I can go down to the other equation, circle my y, and replace it with that. Because y is that, so instead of putting a y here, I'm going to have x plus 25 plus x equals 65. Let's try it. So we have, I'm going to put that in place of the y, x plus 25, and then plus x equals 65. Does that make sense? Do you guys all see what I did?
Yeah.
All right. Now, how many variables, types of variables do I have in this equation? One. How many equations do I have there? One. That's all I need to solve it, right? So, okay, I've got, help me. Jan, what do I do?
You can do x, you can put together 1x and 1x and make 2x plus 25 equals 65, and subtract 25 from both sides, and then have 2x plus 40, and then divide by 2 on both sides, and then you get 1x.
Very nice. X equals 20. Now, always with word problems, always after you get your answer, go back and read the question. What's the question say? Find the...
Numbers.
Oh, there's an S. Am I done?
No.
No. So how do I find Y? I could plug it into either one of these equations. What would you do, Luke?
I put 65 over 20, what x is equal to, and then subtract the negative 1.
You would do what again?
You put 65 over 20 and then subtract negative 45, which would make sense. Because
Why would I put 65
because
over
it's
20?
y plus x equals 65, and you know what x is, so you can just plug that in and then
So
subtract.
when you say 65 over 20, you're not saying 65 divided by 20.
No, I'm saying
Oh, okay.
subtract. If I
So,
say minus
oh yeah, yeah.
65,
So you could plug it into either one of these equations, either one, right? So you got x is, okay, so we've got y plus 20. You're using this equation, is that what I'm saying? What I'm hearing you say?
Well, no, so
Yes.
you do 65 minus 20. Yes.
Well, wait. I'm not asking you to do stuff in your head. I'm asking you to show me your work.
Yeah,
So-
so you do 65 minus 20. And you have what?
Right, but that, I'm doing it as an equation. I'm subtracting 20 from both sides, yes? Right? Okay, y is equal to 45, am I right?
Yeah.
Okay, there we go. There's my answer. I have to circle both my answers. Vista 5, do you guys get that? Now, in my opinion, this would have been the easier equation to substitute it in, because since I'm looking for y, it already says y equals. Do you see what I'm saying? I don't have to subtract 20 from both sides. Oh, well, if x is 20, y is 20 plus 25, that's 45. You see what I'm saying? To me, that's easier. But it's totally fine to use either equation, right? Either one. Okay, so that's number one. Any questions on it?
Can I just want to.
Yeah. Yeah. I'm gonna erase this part. Is that okay? The word. And I'm gonna write another problem. So go ahead and write down the problem as I do it. Number 2. Okay. One number. Can you guys all hear okay? Because the air conditioner's on.
Yeah.
Can? Okay. One number is, I can't hear you very well, so that's why I asked. 5 more than 3 times the other. Their sum is 45. Find the numbers.
Can we just try to do this one?
Wait, I can't hear you. What? Say it again.
Can we just try to do this one?
Yeah, try it. I'll go ahead and try to do it. And I'm going to give you a couple seconds and I'm going to start writing how to do it. See if you can do it in your notes for a second. I'm going to slowly start to solve it so you can start to compare. Did everybody get those equations? So far, everybody's doing what I did? Make sense so far? All right. So far, everybody still with me? Am I way ahead? Am I way ahead of people? Okay. So I've got one answer. So now I'm going to just plug it into this.
Did it? Yeah.
How many people got that? I think I went too fast for some people, so
Yeah.
I apologize. But let's just look at it. Well, you guys can keep writing if you haven't finished. One number, y, is equals 5 more than, ooh, hold on, skip that. More than what? 3 times the other, so I put 3x. And then I go back and I do the plus 5, okay? And then it says their sum is 45, x plus y is 45, right? And then I circle what y is equal to, circle the y in the other equation, and substitute it in, and now I have one equation with one variable, right? And then suddenly I get x is equal to 10.
Wow.
Now I go back to one of my equations, either one, I choose this one, because since I'm solving for y, it already says y equals. And then 3 times 10 is 30, plus 5 is 35. So there, I've got my 2 answers. Pretty straightforward? Yeah, question.
There's a way that instead of doing that y equals 3 times 10 is 5, you can just subtract 45 minus 10 and you have y.
Correct. Yeah, correct. Totally. Totally. Yeah, totally. Yeah, totally fine. Yeah, use your method. If that works for you, do it. Totally fine. Okay, let's try one more. We're kind of running out of time here, but can I erase?
Yeah.
Okay. Okay. This is number 3. One number. So write this as I'm writing. One number is 2 less than another. Period. 5 times the larger . 5 times the larger is equal to 6 times the smaller . Comma, decreased by 4. Find the numbers. Okay, since I have 4 to 5 minutes left of this class, so I'm just going to go ahead and explain. Is that okay?
Sure.
Now, as we start adding more complexity, wouldn't you agree with me? It makes it a little harder to use the guess and check method, right? And so it's really helpful to know how to set up your equations. Okay, the first sentence, though, is your first equation. That's pretty easy, right? One number, that's my y. Another is my x. So suddenly I have y is equal to 2 less than.
Skip it.
Skip it. Go to the x. And then minus 2, right? Okay, that's my first equation. Now it says 5 times the larger. Oh, wait a minute.
The larger is x because it's x minus 2 equals y, so you know x is bigger.
Yeah. See, y is the same thing as x minus an extra 2, right? So y has to be smaller. Does that make you guys see how that works?
Yeah.
Y is smaller. Y is smaller than x. Y is not equal to x. It's 2 less than x. So y is smaller. So I'm going to just remember y is small, right? X is big. All right, that's just helpful for me to know. 5 times the smaller. 5 times y, right? Because y is smaller.
5 times the larger.
Oh, sorry. I read it wrong. Sorry. 5 times the larger. Right. 5x. Right? 5 times the larger, 5x, is equal to, that's easy, 6 times the smaller, 6y, right?
Yeah.
And then it says decrease by 4, minus 4, right? Does that make sense?
Yeah.
Fist to 5, everybody understands how I got this?
Yeah.
Yep,
Yes.
okay, awesome.
Yes.
So now, I've got y is equal to, and I circle what y is equal to. X minus 2. Now this is the trick. Watch this. Very important. All eyes. Really pay attention. I am circling, that's what y is. I am circling just the y. I am not circling the 6.
Yeah.
Right?
Uh-huh.
And when I plug that in, I have to use parentheses, right? And I'm going to have to use the distributive property.
Oh, no.
Okay? So here we go. 5x is equal to 6. And now instead of y, I'm going to use parenthesis, this blob here.
Fine.
X minus 2, parenthesis, and then minus 4.
Yeah.
Everybody see what I did?
Yes.
Those parentheses are important because you're multiplying the 6 times both of the numbers in there, right? So now we have 5x is equal to 6x minus 12 minus 4. Right?
Yeah.
What's minus 12 minus 4?
Oh,
No.
I don't know.
Minus 16.
Minus 16.
Oh, wow.
If the signs are the same, you keep the sign, right? Here's 0. You go to the negative 12 and negative 4 more. So it's going to be negative 16. So 5x is equal to 6x minus 16.
I subtract 5.
And I'm going to subtract,
No, 6.
I'm going to subtract 6x.
Wait, go back.
Subtract 6x. Now I'm going against what I told you. I told you to always try to subtract the smaller number. Do you agree with me?
Yeah.
And I just subtracted the larger number. The only reason is I'm lazy. And I want to
Same.
solve this as fast as I can. Right? And I already have negative 16 on this side. You see what I'm saying? So I want my x's on the other side. If I subtracted the 5x from both sides, I'd have 0 equals 1x minus 16. Then I'd have to add 16. It's just an extra step. I'd rather do this. And that gives me negative x is equal to negative 16. Now, if in my head I divide by negative 1, right?
Then one.
That gives me x is equal to positive 16. Do you guys see what I did?
Yeah.
Everybody understand?
Uh-huh.
All right, if x is positive 16, what is y?
14.
Y is 14. Right? X is 16. And there's my answer. All right, that's awesome. So I am going to stop the lecture here
My brother.
and give you guys the homework.